In this video, we're going to solve the tutorial sheet on work, energy, and power. Basically, tutorial sheet 7, these are the questions that we're going to solve. We're going to solve all of them. Okay. Now, before we start solving these questions, what are some of the things that we're supposed to understand, on work, energy, and power? So first and foremost, you have to know what work is. Okay, that work is just your force multiplied by your distance. Now this distance is in the direction of the force, therefore your force in this case, because there's an angle that is made to be F cos theta, so in this case it is FD cos theta. You are not supposed to forget that, and that is very, very important for you to know. So now, what will be the units? You know that force is measured in Newton, distance or D is measured in meters, so that would be 1 Newton meter. Now 1 Newton meter is equivalent to 1 joule. Okay, therefore weight is measured in joules, so that is very important for you to know. Then you also have to understand what energy is. Now, what energy is, we're just talking about ability to do that work. Now, your ability to do that work is because the energy. Okay. Now, from your law of conservation of energy, we know that energy can neither be created, it cannot be destroyed. It can only be transferred from one form to another. Basically, there are different forms of energy. There's heat energy, there's a lot of energies. Okay, however, as far as this topic is concerned, you're going to talk about two types of energies. You're going to talk about kinetic energy, and you're also going to talk about potential energy. Now, a combination of potential energy and kinetic energy gives you what we call mechanical energy. Okay, mechanical energy. But now, what is kinetic energy? When we're talking about kinetic energy, we're just talking about the energy of motion. Okay, there is motion. Okay, the energy of motion, and the way you're going to find your kinetic energy, that it is half mv squared. Then when we're talking about potential energy, it is the energy of position. Okay, or what we call stored energy. In this case, you're going to find it as mgh, meaning the weight with respect to a certain height. Okay, so if it's an incline and an object is going in this direction, okay, it's going to have a certain weight, which is mg. However, it's going to move a certain height. That's how you're going to find the potential energy. Therefore, what that means is that potential energy is going to be gained. Okay, just like work, energy is also measured in joules. Okay, like that. So that is very important for us to know. Then when we're talking about power itself, what is power? Okay, now that you've got the energy to do that work, how fast are you doing that work? That's what power is. Okay, how fast are you doing that work? It is the rate we're talking about, time. So the rate at which work is being done, and it is also the rate at which energy is being transferred. Okay, so we know that energy is not done, energy is transferred. We know that work is done, work is not transferred. So basically, those will be the two definitions. So now, if those are the basic definitions, what are the formulas now for power? So you're going to find your power as the work done multiplied by the time. Okay, the time at which you are doing that work. However, you can also find your power as kinetic energy if you relate it to energy being transferred. So kinetic energy over your time. Okay, so basically that's what it means. But now you're able to see that there's a work done and the kinetic energy, and they are equal to each other. So because of that, we're going to also talk about what we call the work energy theorem. Now, according to the work energy theorem, we're just saying that the work done is equals to the change in kinetic energy. I don't want you to forget this principle, because it applies in a lot of instances. However, sometimes there's also the last formula for power that you might also want to look at. Power is also defined as force multiplied by your velocity. Now, force multiplied by velocity, here there is a condition. When the force and when the distance are in the same direction, that's when you use this formula. And power itself is measured in watt, and the watt is just equivalent to 2. We know that kinetic energy or work done, they all have the same unit, which is joule. Okay, then we're dividing by time. Time is measured in second. So 1 watt is equals to 1 joule per second. So basically, these are just some of the principles that you're supposed to understand. Now that we've talked about these principles, let's solve our questions. So these are the questions that we're going to solve, all of them in your tutorial sheet. So let's start with the first one. We are taught to calculate the work done by a force of 30 Newton in lifting a load of 2 kg to a height of 10 meters. Acceleration due to gravity 10 meters per square second. Okay, so how are we going to solve our question? Now, this is the work done, and you've lifted this object. Because you've lifted, there's an aspect of what? Potential energy. Potential energy is going to be gained because of the height. Okay, so in this case, the work done, or we're just going to say the potential energy, which is equals to mgh. Now, the mass, we've been given that it is a 2 kg object multiplied by the acceleration due to gravity, we've been given 10, multiplied by the height that we've been given. The height we've been given 10. Okay, now if you go this route, okay, not really the potential energy, we're finding the work done actually. So for us to find the work done, let's first find that work done is equals to force multiplied by the distance. In this case, the distance will be the what? The height. Okay, so the force in this case we've been given 30 Newton multiplied by what is the height? The height we've been given at 10 meters. Okay, therefore what is going to be our answer? We're going to have 300 Newton meter. A Newton meter, we said it is a joule, so we're going to have 300 joules. Okay, now this will be the work that will be done. However, we're also going to have the work that will be done due to potential energy, the one that we are just from finding, which we wanted to find at first, which is potential energy will be mgh. The mass is 2, the acceleration due to gravity is 10 multiplied by the height, which is also 10. So we're going to have 200 joules. Okay, now that we've got 200 joules, what would be now the net work? Because this is the work that you are doing, you as you are lifting it. Okay, however, the load is also going to do work in terms of potential energy, and that is the work. But now what will be the net work? Okay, what will be your net work? So the one that you applied minus the work that was done by due to gravity for this object. So in this case, we're going to just do 300 minus 200. What are we going to get as our work net? Our total work done, we're going to have 100 joules. So basically that will be your answer for 1. Let's come to question number 2. Now we're told that a box is pulled with a force of 25 Newton to produce a displacement of 15 meters. Okay, if the angle of displacement is 15 degrees, find the work done by the force. Okay, so what are we going to do? So what information do we have as the data? We have a force of 25 Newton, a displacement d of 15 meters. What other thing? We have an angle that is between them. An angle theta we've been given is 15 degrees. Okay, so what are we going to do? Let's find the work done. Okay, so what will be the work done? So you know that work done will be equals to your force times the distance times the cos theta. Okay, the angle. So in this case, what is the force? The force we've been given that is 25 multiplied by the distance we've been given that it is 15 times cos, 15 degrees Celsius, or 15 degrees actually. Okay, then what are we now going to have? 25 multiplied by 15, I'm getting 375 multiplied by cos 15 degrees, I'm finding 0.9659. Okay, now that I've got that, the answer that I already have multiplied by 375, I'm getting 362.2. That is our answer. In this case, since it is work, it is joules. Okay, basically that's how I'm going to solve that question. Now, question number 3, we are told that an object of mass 2 kg falls from a height of 5 meters to the ground. What is the work done by the gravitational force on the object? Okay, so this is work due to gravity. Okay, neglect air resistance and take g to be 10 meters per second. Okay, so what data have we been given? We've been given a mass of 2 kg. We've also been given a height of 5 meters. Then what are other thing? Acceleration due to gravity 10 meters per square second. Okay, so now let's calculate first the weight force. So the weight force, we know that weight itself, it is mg. Okay, so what will be our mg? In this case, we've got a mass of 2 multiplied by the acceleration due to gravity, which is 10. Our work in this case, it will be 2 multiplied by 10, that is 20 newton. That will be the weight of this object. Now, what about the displacement in the direction? We know that if you look at the displacement, it is going down. Okay, so even the weight is also going down. It is in the direction of the same force. So therefore, we have to now find our work. Now, the work that is going to be done here is the work due to gravity because it's being put down. Okay, so what will be the work? So the work will be force multiplied by the distance. There is no angle that is there. So in this case, the force was just from finding, or the weight, which is 20 newtons multiplied by the distance. We've been told that is 5 meters. Okay, therefore just multiplying the two. 20 multiplied by 5, that is just 100. Okay, joule. So basically that's how we are going to solve our answer. What this means is that the work done by the gravitational force as the object is moving down 5 meters is 100 joules. Okay, so that is very important for us to understand. Now, as you continue solving questions, you can pause the video, try them by yourself, then you compare with what you are solving, just for to maximize your understanding. Let's go to question number 4. Now, question number 4, we are asked how far must a 5 Newton force pull a 50-gram toy car if 30 joule of energy are transferred? Okay, very, very nice question. So what are we going to do? So we know that work is equals to force multiplied by the distance. There is no aspect of an angle in this case. We've been given 30 joules of energy. That is the energy that we have. So that would be 30 joules is equals to, what about the force? Have we been given, of course, 5 Newton. What about the distance? Is the one that we are trying to find. How far must it be? Okay, so in this case, for us to find us the distance, we're going to divide by 5 newtons on both sides. So the distance therefore is going to be, 30 divided by 5, that is 6. So distance measured in meters, so this will be 6 meters. So what this means is that the force must pull the toy car 6 meters to transfer that 30 joules of energy. Okay, let's come to number 5. Now number 5, we're told that a stone of mass 2.5 kg is lifted up to the top of a cliff that is 180 meters high. How much potential energy does the stone gain? Okay, so we're talking about potential energy. So what are we supposed to do? What will be the gain in potential energy? What have we been given? We've been given the mass 2.5 kg. What other thing have we been given? Acceleration due to gravity. Okay, we can just say 10 meters per second. What about the height? The height is 180 meters. Basically, we have everything that we need to solve this question, and we said that our potential energy is just equals to mgh. We have everything. So in this case, 2.5 kg multiplied by the acceleration due to gravity multiplied by 180 meters. Okay, so now 2.5 multiplied by 10, that is the 25, multiplied by 180. Okay, the 25 multiplied by 180, what do I have? I'm finding 4,500 joule. So that would be, the stone will gain 4,500 joules of potential energy, okay, as it is being lifted. Question number 6. A student of mass 70 kg runs up a flight of stairs with a vertical height of 5 meters. If the trip takes 7 seconds to complete, calculates the student's power. Okay, so we are trying to find the student's power. Okay, so we know that power is equals to work divided by time. Okay, or if you want kinetic energy, so potential, kinetic energy. But now, since there's no aspect of kinetic energy and the height is being involved, we're going to talk about potential energy. Therefore, we're going to find the potential energy, and it's a potential energy in this case that will be, it will be the potential energy divided by time. So let's find the potential energy, and we said potential energy is equals to mgh. Now what is the mass? We've been given a mass of 70 kg, okay, multiplied by the acceleration due to gravity of 10, multiplied by the height. The height in this case, what are we going to do? We've given 5 meters, so we're just multiplying 7 multiplied by 70 multiplied by 10, that is 700 multiplied by 5. 7 multiplied by 5, that is a 35. Then I've got 2 zeros, so this will be 3,500 joules. Okay, now that I've got 3,500 joules, let me now find the power. So the power in this case, the potential energy, we found that is 3,000. Okay, 3,500 joule over, what is the time? Okay, now the time we've been given at the 7 seconds. So basically we're just dividing 3,500 divided by 7. Now you know that 7 into 35, that is a 5. Okay, then we've got 2 zeros. Joule per second. Joule per second is the same as, this is just the same as 500 watt. Okay, so basically that will be the power. The student's power output will be 500 watt. Okay, let's go to question number 7. Now question number 7, we are asked a motor moves a lift 4 meters between floors in 1.5 seconds. The lift has a mass of 1,850 kg. We're told to ignore friction. Okay, we're told to calculate the weight of the lift. Okay, the weight of the lift. Number 1, how are we going to find the weight? Now you know that the weight is equals to mg, mass times acceleration due to gravity. What is the mass? So we've been given a mass of what? 1850 kg multiplied by the acceleration due to gravity, let's say 10. Okay, if I'm using 10, so what am I going to have? I'm going to have 1800 Newton. Okay, I'm just going to have 2 zeros at the end. So that would be the weight for the first question. What about B? B, we are told find the upward force in the cable when the lift is moving at a constant speed. Okay, so basically what is happening here is, let's say this is the lift. Okay, so you are taking it to the top floor, and let's say this is the ground floor. Okay, now we are going to have the weight, which is the mg that we are just from finding. Okay, now you are going to be moving it at a certain distance. We've been given the distance. We've been given the distance between. Okay, we've been given a distance of 4 meters. This lift, we are saying it is 1850 kg. Okay, okay. Now probably you're going to be using a cable. Okay, that's why they're talking about find the upward force in the cable. Okay, now if you're going to be using the cable is going up because you're pulling it up yourself. However, you're going to have the weight force that is acting in the opposite direction. So the cable in this case, it is acting in the direction of what we call the normal force. Okay, and you know that the weight and the normal force, they are just in different direction. So the force that you found for weight, it will be the same force that will be in the cable. So in this case, for us to find the upward force in the cable when it's moving at constant speed, you are still going to have the same answer as the weight. Okay, so in this case, our answer for B, it is the same 18,500 Newton. Okay, now we come to number 3, or B. We come to C now. Now C, we are asked to find what is the work done by the motor. So work done, we are saying it is force multiplied by the distance. Okay, now the distance in this case is the height. Now we've already found our work done, which is 18,500 Newton. That is the force multiplied by the 4 meters that it is going up. So therefore, just multiplying the two. So I already have 18,500 on my calculator, so I'm going to multiply by 4. I'm going to get 74,000. So this is work done, so it will be joules. So basically that's how I'm going to find my work. Now let's solve the last question. How do we solve the last question? D. Compute the motor's minimum power to raise the motor at a steady speed. Okay, now we're talking about the power, and we said power is equals to work done over time. Now what is the work done? We're just from finding the work done, which is 74,000 joules divided by the time. Have we been given the time? Yes, 1.5 seconds. So that is 1.5 seconds. So what are we going to have? I already have my 74,000 on my calculator, so I'm just dividing by 1.5. That is giving me something like 49,333 watt. So to be what? However, I can approximate it to be, maybe even around that. So it's still fine like that. So that's what you're going to find like that. That will be your answer. So let's go to question number 8. Now question number 8, we are told that a moving object possesses kinetic energy. The kinetic energy of an object will increase if its mass and or velocity increases. We are told to find the kinetic energy of a cricket ball of mass 160 grams thrown at 2 meters per second. Okay, This is a very nice question. So not very complicated. We're taught to find the kinetic energy of a cricket ball. Okay, so you know that kinetic energy, this is A. So kinetic energy, you know that it is half mv squared. So we're going to say half multiplied by the mass. They've given us that it is 160 grams. Now 160 grams, you have to convert it to kgs, because that's the SI unit for the mass. So I'm going to divide the 160 divided by 1000. Okay, so that would be 16 divided by a 10, and that will give me 0.16 kg. Okay, so that is what I'm going to put here, 0.16 kg multiplied by, what is the velocity? We've been given that it is 22 meters per second. So I'm going to put 22 meters per second. Now this is squared. Okay, so what am I now going to have? Okay, so half of 0.16, that is giving me 0.08 multiplied by 22 squared, that is giving me 484. Okay, the 484 that I found multiplied by 0.08, I'm getting 38.72 joule. So basically this will be the kinetic energy for this ball. Now let's now solve B. Now B, how fast will the ball move if it has 180 0.5 joules of kinetic energy? So how far? We're talking about how far. We're talking about what? The distance. Okay, how fast? Oh, actually we've been asked how fast. How fast it is the velocity. Okay, so how fast is it going to move? Now we have everything that we need. We already have the potential energy, everything, the mass. So what are we going to do? We are saying kinetic energy is equals to half mv squared. Now if I were to make v squared the subject of the formula, what are we going to have? Okay, so it means I can multiply by okay, let me first multiply the whole equation by 2. Now if I multiply the whole equation by 2, this side I'm going to have 2 ke will be equals to, the 2 and the half are going to cancel. I'm going to remain with mv squared. Now for me to remain with my v, I'm going to divide by m on both sides. Therefore my v squared will be equals to 2ke divided by m. Okay, that is what I have. Allow me to wrap that, but I'm not going to wrap the last part because that's the kinetic energy that we found. So I'm going to replace it there where we have kinetic energy. Now for me to remain with my v, since this v squared is equals to 2ke divided by m. So for me to remain with my v, I'm going to square root on both sides. I'm going to now have my v to be equals to the square root of that. Okay. Now what is 2 multiplied by? So we have 2 multiplied by the kinetic energy. Now the kinetic energy we've been given, actually it's not the one that I presumed. This one is a different one. We've already been given a kinetic energy. How fast will the ball move if it has this amount of kinetic energy? So I'm multiplying 2 multiplied by 180.5, okay, divided by, what is the mass of this object? The mass we've been given as okay, it's this one 16 grams. Okay, see, 160 grams. We had found that the mass was 0.16 kg. Okay, make sure that it is in SI unit. Now that we've got this, let's now solve. Now what is it? What are we having? We're finding the square root of 2 multiplied by 180.5 5 joules, what do I have? I'm finding 361 divided by 0.16. So the answer that I have divided by 0.16, I'm finding 2256.25. So that is what I have. Now the square root of that, what does it give me? I'm finding now my V to be 47.5 meters per second. So this will be the velocity. That is how fast it is going to move. Okay, let's now solve question number 9. Now question number 9, we are asked a billiard ball rolls off a table and hits the floor at 5 meters per second. What is the height of the table? Now if we were to assume this and just picture it, let's say this is the table, okay, and the table has a stand like that. Let's say this is our table, not really drawn to scale, we're just trying to approximate things. And let's say this is the floor and the table is on that floor. So we know that there's going to be a height when this one falls, right? You're going to have a height. What other thing are we going to have? If the ball is going to be rolling, it's going to be going in that direction, okay? So basically, what are we going to have if we now consider things? This is the top of the table and this is the ball, and it's rolling, it's going in this direction, okay? And they've told us it's moving at 5 meters per second. So they're asking us what is the height this ball will fall at. So we're trying to find the height, and this is the floor. So basically this is a scenario that we have, okay? So what are we going to have? Now what's the height? How are we going to find the height? So I'm thinking about something. So we're going to go back to our Newton's laws of motion. Now that formula, which is v squared is equals to u squared plus 2as, okay? Now since this is due to gravity, I'm not going to put 2as, I'm going to put 2gh. Why 2gh? H is the s, the height. G is the acceleration due to gravity, because this object is falling, okay? Now our initial velocity is going to be 0, so the v squared in this case will be equals to 2gh. 2gh. Now have we been given the velocity? Of course we've been given it is 5. So all we have to do is just to find now the height. So we're going to divide by 2g on both sides. Therefore the height will be equals to v squared over 2g. Now what is our v squared? V, we've been given that it is 5 meters per second divided by, this is squared. What about our 2? 2 multiplied by our g. If we're going to take g as 10, our acceleration due to gravity as 10. Now 5 squared, that is a 25, divided by 2 multiplied by 10, that is a 20. Now 25 divided by a 20, what do I have? Let me use my calculator. 25 divided by 20, I'm getting 1. So the height in this case would be 1.25 meters high. Okay, so basically that's how you're going to find your height. Okay, so we have the last question on the incline. Okay, so basically how are we going to solve this one? So we're told a crate of mass 10 kg is pulled up a rough incline. Now they've told us it's rough with an initial speed of 1.5 meters per second. The pulling force is 100 newtons parallel to the incline, okay, which makes an angle of 20 newton with the horizontal as shown in the figure below. The coefficient of kinetic friction is 0.4 and the crate is pulled 5 meters. How much work is done? And all these are the questions. Let's just come up with the data. So what have we been given? We've been given the mass of this crate. It is 10 kg. It's pulled upon a rough incline with an initial speed. So the speed, okay, what told is 1.5 meters per second. The pulling force, it is 100 newton parallel to the incline, okay, which makes an angle of 20 degrees. So the angle, we're able to see that it is 20 degrees. So theta is 20 degrees. The coefficient of kinetic friction, nu k, we've been given as 0.4, okay, that is the coefficient of kinetic friction, okay, because we've been told it's a rough surface and it is pulled and the crate is pulled 5 meters. So the distance, it is 5 meters. Now A, we are asked how much work is done by gravity, okay, work done by gravity. Now what is going to be the work that is going to be done by gravity? We know that work done by gravity, it is the potential energy, right? In this case it is mgh. Now what is the mass? We've been given that it is 10 multiplied by the acceleration due to gravity. Now if I take, in this case, let me try to take acceleration due to gravity as 9.8 multiplied by the height. The height, what have we been given as the height? So it means we're supposed to first find what the height is, otherwise we cannot find this question. So let's find the height. So if I'm going to draw, just to indicate like that, this is the hypotenuse. The height is here. How are we going to find the height according to our SOHCAHTOA? So opposite to this angle, you're able to see it is the height. Then the hypotenuse is that. So we're going to use the sine. So we're going to say sine theta will be equals to opposite, which is h, over height, which is 5. Okay, now for us to find the h, therefore h will be equals to, if I make h the subject to the formula, I'm going to have sine theta multiplied by 5. Now what is sine theta? So that is 5 multiplied by sine theta. Now what is our theta? Our theta is 20 degrees. Okay, therefore now you solve 5 multiplied by sine theta, 5 multiplied by sine 20. Sine 20, the answer multiplied by 5, I'm getting 1.71. So this will be the height, 1.71 meters. So I'm going to put it where the h is here. Okay, so I can put it here, 1.71 meters. Now what am I going to have? I already have 1.71 meters on my calculator, so I'm going to multiply that by 10. Then I multiply again by 9.8. So I'm getting negative 167.6 joules. Okay, so this is how much work is done against gravity. Okay, so that will be the work that will be done by the gravity. Okay, because you are forcing it to go up. You know that mostly gravity coming down, it is positive, but when you're going up, because you're going against it, so that's why you're finding out, we'll put our answer to be a negative. Okay, so basically that's what we have as the first part. What about B? B, we're told how much work, how much energy is lost due to friction. Okay, so energy that is lost due to friction. So what will be the energy? We know that work, how much work, how much energy. So it is work done is still the energy. So work done lost due to friction, it will be force, or in this case the frictional force multiplied by the distance. Okay, now the frictional force, we know that the way you find your frictional force, the force due to friction, we said it is nu k multiplied by the normal force. Now we've already been given the coefficient of kinetic friction, which is nu k. We have to find the normal force. The normal force, we know that it is mg. Now what is mg? The mass, we've been given that it is 10 multiplied by the acceleration due to gravity, okay, multiplied by the acceleration due to gravity. What are we going to have? Okay, mass, that is like 10, then 9.8. Okay, so mass multiplied by 9.8 multiplied by, then don't forget we have an angle. So in this case, let me just put it together in the normal force. So in the normal force, I was going to put the cos theta, because I don't want it to compromise here, because you know that it will be FD cos theta, right, as the work. So let me just find it in advance. 10 multiplied by 9.8 multiplied by sine, multiplied by, not sine, cos 20. So the normal force, I'm finding it to be 98. Where can I write it? 98 point, I'm finding not 98, I'm finding 92.1 Newton. So this that I've found, it is, you know, the normal force. Now the normal force that I've found multiplied by the coefficient of kinetic friction. The coefficient of kinetic friction we've given that is 0.4. So that is this formula. So the normal force multiplied by the coefficient of kinetic friction, which is 4. What do I have? Okay, what do I have? 92.1 multiplied by 0.4. Therefore the coefficient of kinetic friction, I'm getting the frictional force, I'm getting 36.8 Newton. Okay, now that I found the frictional force, I can now just replace it. So basically I'm going to put the frictional force is 36.8 Newton. Now don't forget, this is friction. Friction always opposes motion, so I'm going to put a negative multiplied by the distance. The distance, we've been given that it is 5 meters, so I'm just multiplying now. Negative 36.8 multiplied by 5, I'm getting negative 184.2 joule. This will be the work done due to friction. Okay, that will be the work done due to friction. Okay, we found some of the questions. Let's now go to C. Okay, okay, is there anything that we need from what we've just solved? A, B. Now let's go to C. Now C, we are told how much work is done by the 100 Newton force. Okay, so the 100 Newton force, the one that you're applying. Okay, now you know that work done, it's the same principle, saying force multiplied by distance. Okay, so this force is what is the force? We've already been given is 100 Newton. So there's nothing else to finding. Otherwise, you're supposed to do mg cos theta. But they've already given you, which is, so we're just going to get that. 100 multiplied by a 5, which is our distance. In this case, 100 Newton multiplied by 5, what do we have? Is going to be positive 500. I've put positive because it is not friction, it's the one that you're applying. Okay, so that is very important for also us to understand. Let's come to D. So this one we found 500. Okay, work done, we found that it is 500 and it's positive. Now what about, what is the change in kinetic energy of the crate? That is D. What will be the change in kinetic energy? D, we're trying to find the change in kinetic energy. So what is going to happen? Now you are going to realize that the change in kinetic energy itself, how many energies have we found here? So we are going to have the work done that has been done by friction plus the work done that has been done by gravity plus the work done that was that was applied. Okay, those, that will be the change in kinetic energy. So what are we going to have? The work that was done by friction. Okay, let me start with the work that was applied, then I put friction last. Work done that was applied, it is a 500, the one that we're just from finding. Then the work that was done due to gravity, we found that it was negative 167.6, this one, mgh. Okay, then the work done due to friction, we were just from finding it, is this one, negative 184.2. So basically that's what we have, and we're just supposed to add to find the change. So initially we had put 500 newtons on this, we're pulling it to 500 newtons. However, 167 due to gravity was pulling us down. Then there was also friction, 184. Basically we now want to find the energy that was, in terms of change, how much has changed. So I'm just going to do everything. 500 minus 167.6 minus 184.2. I'm finding positive 148.2 joule. So basically that is what I have. Now we're coming to the last question. This is E. Okay, E, we are asked what is the speed of a crate after being pulled 5 meters per second. So what will be the speed? Okay, so what will be the speed? So allow me to just rub on top. Okay, this side. So the speed, we're going to consider kinetic energy. Kinetic energy is half mv squared. Now in this case we're talking about the kinetic energy final and the kinetic energy initial. Okay, that is very important for us to understand. So what will be the initial first? It will be half multiplied by the mass. What is the mass? The mass is 10 multiplied by the initial velocity. We were told that initially it had the initial speed of 1.5. So I'm going to say 1.5 squared, and I solve everything. So the half of 10 is 5 multiplied by 1.5 squared. I'm finding 11.25 joule. That is the initial. Okay, initially that was the kinetic energy. What about the final kinetic energy? The final kinetic energy, it is just what we are just from finding, this one. Okay, So if that is the final kinetic energy, then what are we going to do? Therefore, the kinetic energy in total, we're going to add 11.25 plus the one that we're just from finding, 148.23. That would be the total kinetic energy. Now if I add 148.23 plus 11.25, I'm getting 159.4. Okay, let me just write it down. I'm getting 159.45 joules. Okay, 159.45 joules. So that is the kinetic energy. Therefore now I can replace to find out what the distance, the velocity was at that. So what do we now do? We are saying kinetic energy is equals to half mv squared. We found our kinetic energy to be 159.45 is equals to half multiplied by the mass. The mass, it is 10 multiplied by the v that we're trying to find, the v squared. Okay, what are we now going to do? I'm just now going to you know that half 2 into 2 is 2 is 1, 2 into 10, that is 5. Therefore I'm going to divide by 5 on both sides so that I just remain with v squared on the other side. So therefore v squared will be equals to 159.45 divided by 5. So for me to find my v, I'm just going to square on both sides. So it will be the square root of 159.45 divided by 5. Okay, so what do I have? So I'm finding 159.45 divided by 5. I'm finding, so this will be the square root of 31.89. Then the square root of that, what do I have as a final velocity? I'm going to have 5.65 meters per second. So basically that's how I'm going to find the speed. So basically this is how you solve, questions on work, energy and power. Wishing you all the best in your exams, and don't forget to subscribe, to our channel.